Okay, the next lesson in geometry is called tangents. Okay, we've done tangents in trigonometry and right triangles. This is different though. Okay, so a tangent to a circle. A tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. Okay, so if you look at the diagram below, this is a tangent line. Okay, so I'll just say line L is a tangent line because it intersects the circle at exactly one point. Okay, the point where a circle and a tangent intersect is called the point of tangency. Point of tangency. So that would be point P. So I'll say point P is the point of tangency. Okay, here's the theorem, the first theorem for today. It says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So for example, if you know that this line right here, line RT, if you knew that was tangent to the circle, then you can draw this segment from the radius to the point of tangency, and it's perpendicular to it. That means you have a right angle right here, and right here. Okay? That's the first theorem. So here's the first example today. ED is tangent to circle F. Find X. Okay, so since ED is tangent to the circle, it means we have a right angle right here. So it means we're going to solve for X using the Pythagorean theorem, and you may have this answer memorized ahead of time, but I'm going to do 3 squared plus 4 squared, those are the legs, equals to hypotenuse X squared. So 9 plus 16 equals X squared. 25 equals X squared. And then you get the square root of 25 equals X. And you only want the positive one because you're doing a distance. So X is going to equal 5. What if I went one step further and I asked you to find pencil. What if I went one step further and I said find each part of the hypotenuse? Meaning, what if I said what's this part right here? Then I said what's this part right here? Okay. Well, you should know that this part right here is 3 because all the radii are congruent, which would mean that this part right here would be 2. Okay, but I did not ask you for that, but I could ask you for that. So this part was 3 and this part was 2. Let's move on. Example 2. RS is tangent to circle O, so that means you have a right angle right here. That was the theorem from the first page again. Find X. Okay. So first thing I'm going to do is I'm going to label QT, and you should know what QT is. QT is 12 because all the radii are congruent. So QT is 12 feet. And now we're going to go back to the good old Pythagorean theorem. X squared plus 12 squared equals 20 squared. Okay. X squared plus 144 equals 400. Then you're going to do 400 minus 144, and you get X squared equals 256. take the square root of each side, and you only want the positive square root because it's a distance. You can't have a negative distance. And you might have this memorized. This is going to be 16. Okay. This next theorem is the converse of the theorem that we just did. Okay. So the theorem that we just did, just to go back to it, says if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. And now we're going to do the converse. That's when you switch the hypothesis and the conclusion. If a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. Okay, so it's the converse of what we just did. So if you knew that OR was perpendicular to RT, then you can conclude that RT is a tangent line. Example 3. Determine whether KL is tangent to circle M. Okay. 1 second. Okay, so again, the question is, I'll put a question mark, okay? Is that a right angle? Question mark right there. Is that a right angle? I don't know, but let's see if we can find out. We've done problems like this before, determining if it's a right angle. It's a right angle if the leg squared plus the other leg squared equals the hypotenuse squared. So let's see what we got. Let's do 6 squared plus 10 squared over here. And then off to the side, we're going to do the square root of 136 squared. So the question is, what is the square root of 136 squared? You should know that right away. It's just 136. Because square rooting and squaring are inverses. It's like saying, what's 10 plus 5 minus 5? It's still 10. Okay? The square root of 136 times the square root of 136 is just 136. Now let's do 6 squared is 36. 10 squared is 100. Add those together and you get 136. Notice how these numbers are the same? So it means yes, KL is tangent to circle M. So I'll say yes. I'll say because 6 squared plus 10 squared equals square root of 136 squared. Okay. Moving on. Here's another theorem. If two segments from the same exterior point, meaning a point outside, if two segments from the same exterior point are tangents to a circle, then they are congruent. So in this diagram, you have a point on the exterior of the circle, which is point A. We have two tangent lines. AB is a tangent and AC is a tangent. Since they're both coming from the same point outside the circle, it means that they have to be congruent. So you can conclude that AB is congruent to AC. Okay? Example 4, find X. Assume that segments that appear tangent to circles are actually, in fact, tangents. So, AB is congruent to AC because they're both tangent to circle R and they both come from the same point outside the circle, in this case, point A. Also, AC and AD are congruent because they are both tangents to circle Q, and they both come from the same point on the exterior, point A. So I'm going to label, if this has one tick mark on AC, I'll put one tick mark on AD. And due to the transitive property of congruence, all three of those segments are congruent. So I can say that 6x plus 5 equals negative 2x plus 37. Add 2x to each side. Subtract 5. 8x equals 32. X equals 4. We might as well just do a quick double check to make sure it works. If you do AD, 6 times x plus 5. 6 times 4 is 24. Plus 5 equals 29. Let's double check AB. Negative 2 times x. Negative 2 times 4 is negative 8. Plus 37 equals 29. So they both equal 29, so they're congruent. So I'm very confident that x equals 4 is correct. Let's do another problem like that. Example 5. GH and HK are tangents to circle F. Find GH and HK. So since they're both tangents to circle F and they come from the same exterior point, it means that they're congruent. So this segment is congruent to this segment. Okay? So GH is congruent to HK, so it means that they're equal. 4 plus 2a equals 5a minus 32. So it's going to give you negative 3a equals negative 36 when you subtract the 5a on each side and subtract the 4. So a equals 12. And then you have to find each segment. You have to find GH and you have to find HK. So GH equals 4 plus 2a. So 4 plus 2 times 12. 4 plus 24 is 28. Then let's find HK. It should be the same answer, hopefully. 5a minus 32. 5 times 12 minus 32. 60 minus 32 is 28. Okay, so earlier in the unit, we talked about circles can be circumscribed about a polygon. So just in case you forgot what that means, let's say I have a circle right here. Let's go with the pentagon. Here we go. I just drew a pentagon and I drew a circle around it. That circle is said to be circumscribed about the polygon, about the pentagon in this case. Okay. So recall that circles can be circumscribed about a polygon. Likewise, polygons can be circumscribed about a circle. In other words, the circle is inscribed in the polygon. So here's an example down here. Notice that the vertices of the polygon do not lie on the circle, but every side of the polygon is tangent to the circle. Okay, so every side of the polygon is tangent to the circle. Here we go. Example 6. Circle A is inscribed in triangle ABC. Find the perimeter of triangle ABC. So we're going to use the fact or the theorem that tangents that come from the same point outside the circle are congruent to each other. So if this is 10, if AD is 10, then AF is also 10. If FC is 8, then CE is also 8. And if DB is 15, then BE is also 15. Find the perimeter of triangle ABC. The perimeter is when you add up all the sides. So 10 plus 10, plus 15 plus 15, plus 8 plus 8. So the perimeter is going to equal 20 plus 30 plus 24. The perimeter is going to equal 74. I think I did that wrong. Did I have that wrong? No, it's not 74. I knew it. 10 plus 10 is 20, plus 15 plus 15 is 30, plus 8 plus 8, 66. I knew it didn't sound right. 66 centimeters is the perimeter. Okay. Example 7, working backwards now. Circle O is inscribed in triangle PQR. Triangle PQR has a perimeter of 88 centimeters. Find QI. Okay, so first things first. If PX is 15, then PZ is also 15. And if ZR is 17, then YR is also 17. For now, I'll just put a little x over here. And if that's a little x, this is also a little x because those are the same. Okay. So here's what I'm going to do. I'm going to do x plus 17 plus 17 plus 15 plus 15 equals the perimeter, which is 88. Combine like terms. X plus x is 2x. 17 plus 17 plus 15 plus 15 is 64. So 2x equals 24, x equals 12. And if you remember back to our original diagram, x represented qy and qx. So that means that qy equals 12 centimeters. If I said what's qx, qx also equals 12 centimeters. Okay? Okay, now this last problem is a question I got from the SATs. In the circle below, LM and MN are tangents. Find the measure of angle LON. Now this one is not that hard. So if LM and LN are both tangents, then it means that this is a right angle right here because it's perpendicular to the segment that's drawn. Okay, the radius to the point of tangency, these are both perpendicular. Notice you have a quadrilateral. You should know that all those angles add up to equal 360. So I'm going to say that the measure of angle LON plus 90 plus 90 plus 60 equals 360. Combine like terms, the measure of angle LON plus 90 plus 90 is 180, plus 60 is 240. So plus 240 equals 360. Then subtract 240 on each side, and you get the measure of angle LON equals 120 degrees. Okay. So that's the end of that lesson. That lesson wasn't too bad. It was easier than some of the previous lessons, I feel like. Okay, so that's the lesson on tangent lines.